In this practice, you're going to use the conservation of energy to solve each of these problems. So I wanted to do an example for you, and then I'll be back in class shortly. So in problem 1, a physics student is dropped. If they reach the floor at a speed of 3.2 meters per second, from what height did they fall? So the first thing that I'm going to do in the problem is draw a quick picture to visualize it. So a physics student is dropped, okay, and then we're looking at them reaching the floor. So here's a quick sketch of the scenario. So a physics student is dropped. I know that if the physics student is dropped, his initial velocity is 0 meters per second because he wasn't thrown down at the ground. And then we're looking at analyzing it when the physics student is at the floor. So after I draw a quick sketch, I'm going to record the type of energy that I know that that person has at initially and finally. So I know initially the physics student is dropped. He has no velocity initially. So the only type of energy that this person has is potential because he has a height off the ground. At the end, when the physics student is at the floor, I know that he no longer has a height. So he has no potential energy. And the only type of energy that he has is kinetic. So I know above the ground before he's dropped, he has potential. At the ground, he has kinetic. So then what I'm going to use after I've diagrammed the situation is I'm going to write out my equation. So I know that I'm using the conservation of energy. And the conservation of energy tells me that the total energy that I start with must equal the total energy that I end with. So that's my equation. TE initial equals TE final. My starting energy must equal my ending energy. Well, to start with, the person has potential energy. To end with, the person has kinetic. And I know that those must equal each other. So all I'm going to do is write my equation for potential energy as mgh, and my kinetic energy is 1/2 mv squared. Now I'm going to plug everything in. Mass is in each term, so it can be canceled out. I can divide both sides by mass. It'll equal 1 on each side, and so it cancels out. So all I'm left with is g is 9.8. My height above the ground is what I'm looking for. And my velocity is 3.2 squared. Okay, so what I'm going to do is I'm going to divide both sides by 9.8. Okay, and then I can plug that into the calculator. And h is equal to 0.52 meters.